Hey everybody, this is a video for my intro calc students, and it's just a short video to finish up example 3. Most of today's class is actually going to be taken up by questions people had about implicit differentiation review. But we did finish the example 3 that we started yesterday and ran out of time to finish. Just to recap where we left off, we used our grade 12 skills to kind of find out as much as we could about this equation here. It's a cubic, which tells me right away that one arm goes up and the other goes down, and because it's got a positive leading coefficient, the down is on the left, the up is on the right. And we used the factor theorem to find its factors, which turned out to be, or its zeros, its x-intercepts, which turned out to be -2, -0.3, and -3.7. We can tell it has a y-intercept of 2, and this one has a domain restriction. So all of that gives me a pretty good picture, and we kind of translated all that information to this picture. Now, the domain restriction means that I don't actually make it to, hang on a sec. Yeah, this should be at 1. This should be a solid dot, I just realized. Let me fix that. Whoops. Solid dot, there. So that's the picture we have so far, but what we don't know, what the grade 12 part of the course doesn't tell us, is how high it goes here before it hits its domain restriction, and how low it goes there. So we're going to do those things right now. We're going to see if we can kind of refine this picture a bit. So I'm going to move over, give myself some room, and I'm going to, first of all, do a bit of calculus here on the equation. So first thing we're going to do is we're going to find what f primed of x is. So f primed of x, this was scrap work, so I can just get rid of that. There. So what's f prime, oops. What's f primed of x? F primed of x is 3x squared plus 12x plus 9. And if I set that to 0, it'll tell me my critical values, which means the places where the tangent to the curve is flat, is horizontal and 0. So the first thing I can do is I can divide the entire equation by 3. That makes life a little easier. And then this nicely factors to x plus 3, x plus 1. So I know I have critical values when x is -3 and x is -1, and those do fit in my domain restriction. So I'm going to explore both of those things. One of them might be a they're critical points. One of them might be a local maximum, one of them might be a local minimum, but I have to explore to see if it is. And I'm going to explore that by trying out an interval chart. So my intervals are, so let's see, what are my intervals here? Well, my intervals go from -3.5, which remember is the smallest it can be, that's my domain restriction, and between that and 3, -3 I should say, which was my critical value. And the next interval would be between -3 and -1, which is the next critical value. And then, of course, what happens when you're bigger than -1? Oh, I was going to say just bigger than -1, but no, it's still an interval, right? Because it's bigger than -1, but remember, we're bounded again by the domain restriction of 1. And we need to figure out what's happening and whether f is increasing or decreasing. So that means that we have to explore what happens to the two factors. And then f primed of x. And then we're going to just use f prime of x to tell us whether we are increasing or decreasing. Okay, so pick a number between -3 and -3.5. So -3¼ makes that negative, but a negative times a negative is a positive. So we're increasing on that interval. A number between -3 and -1 would be -2, which makes that a positive, that a negative, which is a negative when you multiply them together. So we're decreasing on that interval. And the easiest number between -1 and 1 to work with is 0. So 0 makes the first factor positive, the second factor positive, which is positive, so we're increasing. So what we can conclude, therefore, when x is equal to -3, which is sort of between this interval and this interval, we go from increasing till we get to -3, and then we get to decreasing. So that means, therefore, this is a local maximum, right? Because we move up and then we move down on either side of this number. And the other thing that we know is that when x is -1, right, we go from, let's see, on the left side of -1, right here, we are decreasing. And then on the right side, we're increasing again. So that means that is a local minimum. Okay, so now that I know that, I can actually find out what those points are. I can figure out that since x is -3 is a local maximum, well, let's see, what is that maximum? Go back to the original equation and find f of -3, which would be -27 plus 6 times 9, what's that, 54, minus 9 times 3 is 27, plus 2, and that's going to actually be plus 2. So f of -3 is 2. So my local max in that zone is -3, 2. And my local min, f of -1, would be -1 plus 6 minus 9 plus 2. So 6 minus 9 is -3, -4, so that's -2. So f of -1 is -2. Somebody double check my mental math. -7, -1, -2. Yep. So that's the point, -1, -2. And now I can go back to this diagram and really refine it. I know now this and this. So I can actually say that my diagram should look more like this now. It should look like we have a, let's see, what is my numbers again? 1, 2, 3, 4. At 3.5, you know what else I could do is I could actually find, I don't think anywhere I actually found f of 3.5, right? Because, and if you're wondering, why is he doing 3.5? Well, because remember, way back at the beginning, that's the domain restriction. So we end at -3.5. So if I run -3.5, I could find that. I won't bother, but you could easily find that. And you can find f of 1 as well. That one's much easier to just do mentally. But even then, I don't really have to worry about it. It's going to be a fairly large number. So it'd be easy to find those numbers. At -3.5, you end up, say here-ish. But you actually go up to your local max at -3, right? So -3 is a local max. And at -3, you go up to 2. So this might be 1 or 1 point something. And then up to 2. So you go up to there, right? So it does that. And then we know, again, we know what our x-intercepts are. We found them last class. Those x-intercepts are -0.3, -3.7. -3.7 is, say, about there, but remember, you don't actually make it to that point. And -0.3, and what was the other one? -0.3 and -2. So -0.3 and -2. So let's put those on there too. So -0.3 might be about there. -2 would be about there. So actually, I'm gonna redraw that. I didn't do that very good. So I'm gonna redraw that as it's a curve. It would have been coming from there, but it curves up. It goes down, and then I know I go to my local minimum of -2, and then I come up through there. I think I had a y-intercept of 2, right? Oops, sorry, y-intercept of 2. And then, of course, I go up to when x is 1 and it ends. And again, I could figure out what that point is very easily. And there you go. Without touching a computer software like Desmos, without touching your graphing calculator, given a little bit of calculus and a lot of bit of grade 12 math, you can pretty easily figure out how to graph these things. Tomorrow, we're going to just go straight to the algebra and not bother with the sketch. We'll do the sketch at the end of all the algebra. And we'll do some ones where we can't actually tell what the x-intercepts would be because we can't factor them or use our grade 12 skills. So all we have to go on are where the local maximums and minimums are. So that's tomorrow. Okay? That's good enough. Thanks for watching.